Hello everyone and welcome to Introduction to Geospatial Technology. This week we are going to talk about what geospatial technology is and what kinds of questions we can answer with geospatial technology. To start with, we need to explore the question of geography. As you know, geography is a science that deals with the description and distribution of physical, biological, and cultural features happening on the Earth's surface. And geospatial technology is a way of studying geography. If we look a little bit closer at geography and the disciplines within geography, we see that geography includes physical geography, human geography, and geographic methods. As you can see, physical geography is the study of seasons, climates, soils, and so forth, while human geography looks more at the distribution of people and cultures on the Earth's surface. This is a bit different than geographic methods, and this is where geospatial technology comes in. Geospatial technology is a collection of technologies that allow us to study both physical and human geography, essentially any type of geography, because it allows us to see patterns and trends. So when we talk about geospatial technology, it actually consists of four related technologies: GIS, or Geographic Information Systems; remote sensing, essentially using satellite imagery to study the Earth's surface; cartography, which is the art and science of map making; and GPS, or global positioning systems. This semester, we're going to focus primarily on GIS, though, and cartography, though there will be some remote sensing and GPS mixed into that as well. So to begin talking about geospatial technology and the application of geospatial technology, we have to have some type of question in mind that we're trying to answer. And it really requires that we think spatially about any particular phenomena. And it requires us to use a process to answer any type of geographic or spatial question that we might have. So the first step in the geospatial analysis process is to ask a question and construct a question that is spatial in nature. For example, what counties in Pennsylvania have an unemployment rate higher than 4%? That's a spatial question because we're looking at the geography of Pennsylvania and trying to find counties that meet that particular condition. Step two then in the process would be to then acquire data that you would need in order to answer that particular question. And in this case, going with the example of counties that have more than 4% unemployment, we would need two different pieces of information. We would need a GIS file of Pennsylvania counties, and we would need to have unemployment numbers for each of those counties. So in a second, I'll show you what geospatial data looks like so you can see how we would use geospatial data to resolve this question. Then the third step in the process is to explore the data, to use the data to turn it into maps, graphs, infographics, what have you, to look for patterns and relationships. So when we would, for instance, potentially make a map of showing unemployment, we might find that maybe northeast Pennsylvania has a higher concentration of counties with a higher unemployment rate than, say, south central Pennsylvania. And that's just a for instance, not necessarily true. Then the fourth step in the process would be to analyze the data. Does the data that or the answers that you got make sense, and what can you do with those patterns and relationships, and what do they mean? How do you explain that then to an audience? So, like, for example, if we found that there was a high unemployment rate in northeast Pennsylvania, we would want to answer the question, well, why is that? What's happening in that region that is leading to that higher unemployment rate than the rest of the state? And then finally, step 5 is to act on those results. Like, and this could be many different things. It could be just, educating others on what the outcome of that analysis was. It could be help make a decision about something or to solve a problem. So many different things can be in that particular category. It all depends as to the nature of the question that you have. So when we think about spatial questions and spatial thinking, I have a number of examples here of spatial questions, like, for instance, what neighborhoods in Harrisburg have an unemployment rate higher than 5%? What counties voted Democrat in the 2016 presidential election? What is located at the corner of 3rd and Harris Street? And sometimes it's something that simple that you just need to know what is there so that you know the conditions of that particular area. Another example is what areas of the shoreline were eroded due to a recent hurricane, or what areas of Pennsylvania have the highest concentrations of citizens older than 65 years old. So all of these are examples of spatial or geographic questions because they have some type of geography implied in them. So what I'd like you to do is just to take a few moments to think about examples of spatial questions that you could be asking. And they can be, again, anything that involves geography and a question. So take a few minutes and you can pause the video and just maybe write down 2 or 3 examples of a spatial question. And by the way, this is my likeness of myself that I took some liberties with that you'll see throughout the semester. So hopefully you were able to come up with a few spatial questions that we could use GIS to potentially answer. But to go into a little bit more detail about geospatial technology and what geospatial technology is, it's, as I said, a collection of a number of different technologies, GIS being one of those geographic information systems. And that's really going to be the focus of the class this semester, is going to be using desktop, web, and mobile GIS. So you'll get experience in all of those areas. And I think you're going to find that the technology is really a lot of fun, especially students tend to really like the mobile technology because you can use your smartphone to be collecting data, creating maps, and doing some really cool types of projects. So we'll be getting experience in all of these areas this semester. Additionally, you will be exposed to remote sensing, which is essentially satellite imagery. We'll only spend a week or 2 on that. We don't spend a ton of time on that. However, there is a course after the Intro to GIS class in remote sensing for those of you that might be interested in that particular area. But it really allows, satellite imagery allows us to look at the phenomena occurring on the Earth's surface, how things have changed over time, looking at everything from like climate change to how glaciers have changed, the size of glaciers have changed over time, to fire severity in certain areas, looking at droughts, looking at any kind of weather phenomena you can think of, volcanoes, all of that. So many different applications of remote sensing that can be applied. Another area that's really interesting and students have heard a lot about recently due to something that has happened down in Mexico in the Yucatan Peninsula is the technology of LiDAR. This was used to find a number of Mayan ruins that in Tikal that were unknown, and many of you have probably seen the National Geographic documentary on this because it's really cool how they were able to see through the canopy of the rainforest to detect all these Mayan temples and ruins, and they found more ruins in a matter of a very short time using this technology than they have found over many, many decades. So it was really a great advance for archaeology and other areas. So as I mentioned, geospatial technology is a series of technologies, GIS, remote sensing, and GPS. So you'll get, like I mentioned, experience in each of those. But the one that I really want to focus on today, and for most of the semester is Geographic Information Systems, and I want to give you an overview of what that is. So next week when we begin using the desktop software, that you have a little bit of an understanding of what's going on when you're looking at geographic data. But a little bit of background about GIS. It refers to three integrated elements: the geography, the information or the database, and the systems. And you see right here, this is the commonplace definition for GIS that's used. I tend not to use it too much just because it's a lot there, a lot in that very short sentence. But what I like to think about GIS as is smart maps. This allows the linkage of a database to a map, and that's really what gives GIS its power, is the linkage of geography to a database. Because of that linkage, we can do two very powerful things. We can make maps based on that data in that database, and we can also ask our map questions and get fast, accurate answers back. So to show you an example of this, let me get out of this and open up Arcgis Pro. This is the software that we're going to be using for the semester. And what you're looking at, as you know, is the continental United States. But what this data is also going to be able to show us are election results for the last 3-4 elections. And you can see over here in my table of contents, it's called election data because it has that information in the table or the database that's associated with it. And I can look at that database simply by going to what's called the attribute table. That tells me all the data that is linked to each one of these states. So I can see that it tells me the state name, the abbreviation. As I scroll over, these abbreviations, EV 0408 means the amount of electoral votes that particular state had in the 2004 and 2008 election. And then this one tells how many it had in 2016 and 2012 election. And as you know, as a result of the 2010 census, the number of electoral votes has changed in some states because of either declining or growing population. And then you see the results from the 04, 08, 12, and then all the way over in the 16 election. So the 04, 8, and 12 is indicated by the R&D, essentially the Republican or Democratic candidate, but the 16 we coded as either Trump or Clinton. Other data that's in this particular data set is what month is their primary. So again, we could ask the map, well, how many states had their primary in March, or we can make a map of that. And I'm going to show you both of how we can make a map based on this information and how we can ask our data questions based on this information. Let me close that. So the first one that I'm going to show you is how we can make a map based on information that's in that attribute table. Right now, we just have a map showing the United States. But what we can do, because of that linkage to the database, we can symbolize it based on that information. So I'm going to go to unique value, and then I pick which field I want to make the map based off of. And I want to show the results of the 2016 election, which candidate won each state. So I can come here to result 16, and it will automatically pick symbols for me for each candidate, which I'm not too happy with, so I can easily change them simply by clicking on them and then changing them. So I'm going to change Clinton to the Democratic blue, and I'm going to change Trump to the red. Oops, got a little quick happy there. Let me do that again. And red. So yes, the white for the outline, and apply. So now I have a map showing which state each candidate won, And you can see that it's symbolized by that. And over here we have our legend that shows us which candidate won each state. If I wanted to go on further, I could label my states, just because, as we know, not everybody knows their states, so labels are very helpful. So look how quick and easy it was to make that map that shows that particular variable. But it's also easy to change this map up really quickly. Let's say that, well, we don't want to show the winner of this, that we instead want to show the what month the primary is in. So again, we can select that and it will automatically give it a color scheme. We can change that color scheme should we wish to. I'm just going to leave it as is for now. But you can see how that easily shows which state's primary is in which month. So again, it's because of that linkage of the geography to the database that we're able to do that. So that's the first very powerful thing about GIS is the visualization factor associated with it. And I'm going to go back to this and change the map back so that everything is colored the same, just for the sake of demonstration for the next topic. But what I'm going to show now is how we can ask our map questions to get fast, accurate results. So let's say I want to know, well, how many states primary was in April. I can go to my map and do what's called a query or a select by attributes, and I can ask my map a question. I can create a new expression and say where the primary month is equal to April. And then if I hit run, it will show me which states meet that criteria. And then if I want to know how many and which ones, I can go to my table and it tells me down here that 7 states had their primary month in April, and then I can see exactly which ones. And I can actually hit this button to show them and remove the others so that it's a little bit easier to look at, and then we have our answer really quickly. But we can also do questions that are a little bit more sophisticated than that. They don't have to be just on one criteria. Let's say that we want to know how many states went for Trump, voted for Trump, and they also had more than 15 electoral votes. So again, I can do that new expression where the result in 2016 was Trump. And then I can add another clause saying, and where the electoral votes were greater than 15. And then when I hit run, again, it selects those states that meet that criteria. And again, if I open up that table, I can see how many and which ones meet that criteria. And we can see 6 out of the 50 states met that criteria. So the power of GIS is really that the fact that we can be linking geography to a database so that we can be asking lots of different spatial questions and getting fast, accurate answers back. So with that, that is the end of the first lecture. For this week, you are going to be going through 2 activities. One has you exploring the Urban Observatory to learn how to ask spatial questions, and the second has you going through a web mapping activity to help you spatially analyze the spread of cholera in 1854 London. So I hope you have fun with the activities this week, and please let me know if you have any questions.